As said earlier on, M2M, Internet of Things, there are many names for this. One name coming from one of the largest companies in the world, General Electric, is Industrial Internet. And I'm very pleased to present Brett May, Head of Venture and Capital and Business Development from Oracle, to actually present your view on Industrial Internet. Welcome, Brett.
Thank you. Thanks. Good morning, everybody. It's great to be here. Thank you for having me. It's great to be sharing the stage with a Tesla. GE had its Minds and Machines conference in Chicago about a month ago. We didn't have a Tesla. We had an undersea blowout preventer from an oil rig. Not quite as sexy, but it's the industrial internet, and that's what I'm here to talk about today, and how this is going to shape our economy for the next 20 years. My talk today is going to cover basically four things. I'm going to talk about the underlying industry trends that we've been hearing about that are making the industrial internet possible. I'm going to talk about some specific solutions that GE is doing, specific things and use cases that we're doing today for the industrial internet. I'm going to talk about the things that we're doing under the covers to make all this possible and scalable. And then finally, I'm going to close with a discussion of how this is going to be good for the world economy, not just for GE, not just for GE's customers, but for everybody, and you'll see some pretty startling numbers. But first things first, I had a coach once who advised me, if you're going to do a presentation in a forum like this, be simple, be clear, and be bold. It's in that spirit that I'd like to bring you all greetings from our investor relations group in the spirit of clarity and boldness. I guess it'll surprise none of you that not everything that we predict comes to pass in exactly the way we predicted. But with that said, here's GE today. $147 billion in revenue. We were founded in 1892 by Thomas Edison. That makes us one of the oldest companies in the world, but still a youngster compared to Ericsson. But we are the oldest company in the S&P 500. We are the only survivor of the original Dow Jones Industrial Average that was constituted maybe 100 years ago. We have a multitude of businesses. About 30% of our business is a series of energy businesses: oil and gas, energy management, power and water, healthcare. We have aviation, transportation, which is primarily rail and mining. We have GE Capital, our financial services arm, and of course the things that people tend to be more familiar with, which is the home and business appliances and light bulbs and those sorts of things. We have 6,000 employees here in the Nordics in GE. And when you add together the imports and exports, about $6 billion worth of business here for General Electric in the Nordic region. What you may not know about GE is that we're also one of the biggest software companies in the world. GE doesn't report this separately, but we have $5 billion of direct software revenue, and that makes us the world's, I think, 13th largest software company. We have 136 separate software offers. We have over 8,000 software engineers spread throughout the company. Software is a very big business at GE, and software is the group that I'm part of. Our headquarters is out in San Ramon, California, in Silicon Valley. We founded that global headquarters a couple of years ago. We've hired 500 people in the last 12 months, and we're growing to 1,000 by the end of next year. And our software headquarters in San Ramon is where we are doing the industrial internet from, and it's the hub of everything that we are doing. That's GE. So now let's get into some of the industry trends that you've already heard some talk about this morning, and some of the things that are affecting. And I'll give you a bit of an industrial spin on it. The first is more data, and this is an example from aircraft. There was a time when the GE aircraft engine had 2 sensors on it and produced about a gigabyte or so a year of data, 10 gigabytes a year of data. We had 3 variables that were averaged. We threw away the raw data because we couldn't store it. Takeoff diagnostics, cruise diagnostics, landing diagnostics, all averaged across the fleet. Now, today, it's different. We have 200 parameters on an aircraft engine. We have 18 sensors and a new GE aircraft engine today produces about 1.5 terabytes of information a week. The fleet is going to produce 100,000 terabytes of information within the next 10 or 15 years. It's a huge amount of data that is out there, and only less than 1% of it is historically has been used because there wasn't a way to move it, there wasn't a way to store it, there wasn't a way to process it in a timely fashion. So that's aviation. Here's another example that I really like. One GE gas turbine can kick out 500 gigabytes a day of data. How much data is that? There are approximately 400 million tweets a day from Twitter. So one of our gas turbines produces more data than Twitter, we think. Also, 500 America's Cup yachts, is the same number. It's a lot of data. That's the first big trend. It's huge. The second is the rise of the machines. In 1980, there were about 300 computers connected to the internet. In 1996, Netscape launched and drove the connectivity of 1 billion people. And we all saw what would happen. Entertainment got digitized, social media, social marketing. My favorite example that I heard, 10 years ago, there were 500 Blockbuster video rental stores in the United States. By the end of next year, there's going to be 0. They're closing the last one. Netflix has essentially put the brick and mortar video rental business out of business. And now 50 billion machines are going to be connected. And what I love is that there's a perfect alignment between myself and GE and Oracle and Ericsson on exactly how many machines are going to get connected. It's 50 billion. That's the number. But there's a fair amount of consensus about this, and it's going to revolutionize what happens. The third big trend is a change in architecture. It used to be that computing power was centralized. It lived in a data center that was privately owned or owned by a government. Then in the 80s and the 90s, the computing power started to distribute out through client server and became distributed around the organization, but still private, still within one organization. And now what we have is consumer-grade cloud technology, where data, storage, compute lives everywhere, and not owned by one company. It's owned by many companies and sitting in many places. This has driven a change in what we can do with our infrastructure at GE. There was a time when all of our machines didn't have any software on them. Now all of our machines do have software on them. And we now can drive end-to-end connectivity on these things through our architecture. So the technical capability to manage and move this data around is dramatically different than what it was. And finally, the fourth big trend, real-time analytics. It's extracting meaning from this data is where the magic happens. And learning from what has happened in the past and what is happening in the present and predicting what is going to happen in the future is a capability that we couldn't do at scale before, but now we're starting to be able to do it. And so these are some mega trends that are happening in our industries and our industrial businesses that we're seeing that are going to drive the industrial internet. So what is the industrial internet? If you put those four trends together, you get a virtuous circle. Starting at the top and going clockwise, you have our machines that produce massive amounts of data. These now go into industrial data systems that we are building together with our partners. You see the meaning is extracted through analytics. The analytics are made available on remote devices, tablets, iPhones. These are things that we didn't have in the field years ago, and now we do. And the data gets into the hands of humans who can then do the work, optimize the machine, and you end up with a virtuous circle where the machine is now performing a lot better than it used to. So what does all this mean in real life? Here's a few examples that I've pulled out. And these are all things that we are doing today. Some of them may just have a couple of customers because it's early days, but these are all real things that are happening. One of my favorites is power generation with wind turbines, windmills. We used to sell individual windmills. Now we sell self-optimizing fleets of windmills. What does that mean? Imagine a hillside that has a number of wind turbines on it. Some of them are doing better than others. They have, each wind turbine has 150 parameters on it that are software defined that can be tweaked. The windmills can communicate with each other, and the ones that are operating more efficiently can communicate parameters and data to the ones that are operating less efficiently, and vice versa. And the windmills can self-adjust. They can optimize themselves like a flock of birds optimizes itself as it moves through the sky. This is the industrial internet for real. And it doesn't stop there. The fleets of windmills can then communicate with storage devices, batteries, to determine the optimal base load. And the wind farms then can communicate with other wind farms to optimize their power inputs into the grid. These are technologies that we're making available today. That's one example. Here's another one from aviation. GE is the #1 vendor of aircraft engines in the world, and we have 25,000 install base right now producing massive amounts of data. And one of the things we're doing is trying to solve what I call is the well folks problem. In the US, anytime the captain of the plane gets on the intercom and says, "Well folks," everything that comes after that is not good news. "Well folks, we've got a red light on engine number 2. Sorry, everybody's got to get off the plane." And so that starts a whole cascade of unfortunate things, right? Everybody gets off the plane has to go away, they get a different plane. Now everybody's delayed, everybody's getting a meal coupon, everybody's getting a hotel room. Oh, we missed the window, now we've got to get a new flight crew. Meanwhile, the plane that was broken, the part's not here, the part's in Phoenix, got to fly the part in. Got to fly the mechanic in from Denver. These things all happen in real life. So what if you could know that red light was going to come on 5 flights in advance using the massive amount of data that's coming off of wing, instead of when the pilot gets in the cockpit and turns on the switch and the red light comes on and then he gets on the intercom and says, "Well, folks," right? What if you could solve that problem? Well, it turns out we have technology that's working on that and solving that problem today. And if you can prevent one instance of an aircraft out of service for an airline, that's real money. That's a lot of money, and I'll get into how much money that is. But this is things that we're doing today. Another thing that we're doing in aviation, and we're piloting this with a Brazilian airline, is a program that helps tune the engine while it's in flight. Engines are used differently for different purposes. Some fly on long-haul flights, some fly on short-haul flights, some operate in hot and harsh and sandy conditions in the desert, some don't. If you can use all this data and tweak the engine for the conditions that it's running in and save just 1% on fuel, that is a massive amount of savings for an airline. That's one of their 2 or 3 biggest costs. It's real money. So that's aviation. Let's talk about rail. It's another solution that we've developed and are using in a few customers. We're piloting this one at the railroad in the United States, where we are scheduling trains based on past data about movement planning, past data and current data about what's happening. We're scheduling crew, we're scheduling pickups, how the trains pass each other, and by using the power of big data and analytics, we've been able to dispatch trains slightly more efficiently and move them, and so that they can use the rail network a little bit more, maybe 2 miles per hour more for a train. What difference does 2 miles an hour make? It makes a huge difference. And I'll tell you how huge in just a few minutes when I start talking about the economics of this. Finally, let's talk about healthcare. A couple of solutions here. One of the interesting problems in healthcare is surgical site is in the surgery, managing the scalpels and the sutures, getting those tools sterilized and to and from the operating room. Turns out that's a major cost driver in hospitals. Something like 30 to 50% of costs in a hospital, in an average hospital, are driven by pre- and post-op logistics, basically, managing those tools. And we have a robotic solution to this that we're piloting in the US with the Veterans Administration, where we basically have several different robots that sterilize the tools, prepare the trays of tools for the for the surgery, move the tools through the hospital down the elevator to the surgery, and then collect them and take them away to the dirty rooms after the surgery is done. This is not a fun job for nurses to do, and there's a nurse shortage in the US. So we can drive some huge productivity improvements, we hope, by using this solution that we're piloting right now. Another solution that we've got deployed in a hospital in the US is helping them manage their bed inventory and their MRI machine inventory. Hospitals, and it's kind of a mechanistic way to look at it, but hospitals work a little bit like factories. Sick patients come in, there's machinery and doctors and nurses and well patients come out. If you can improve the efficiency of how you allocate beds and MRI machines, which are scarce resources in the hospital, you can actually drive substantial cost savings. The pilot that we did in the hospital in Georgia drove out 20% of bed waiting time. And if you think about the throughput that you can have on a healthcare process, this improves outcomes. People are waiting less, doctors are waiting less, patients are waiting less. That's valuable to everyone. It's valuable to the patients, it's valuable to the hospitals. Same thing with scarce resources like ultrasounds and MRI machines that have to be scheduled. So we have advanced data and analytics around all of these things. So that's, these are all some real examples, real results. We have announced 24 industrial internet solutions. This is all out on our website since Q1 of 2012, which is when we really got started in commercializing these things as industrial internet. We've achieved some good financial results. This year, through Q3, we've gotten about $400 million in orders combined across the solutions, $290 million US in revenue. We're working on the next 24. Actually, I think it's 30 that we're going to launch over the next year or so. And to be clear, on a couple of these points, we're at the start of a long journey. Let me go back to a couple of these. I talked a little bit about revenue and how it's $400 million in orders is great, but really the story is broader than that. It's about services. You see, GE, when we sell a large aircraft engine or a locomotive to a customer, we also sell a multi-year service contract. That's how actually the company makes a lot of its money. And us being able to execute successfully and deliver successfully against that 10-year, 15-year, 20-year services contract actually drives a lot of the profitability of the company. And we share the risk and reward with our customers through that services contract. And if we can optimize the services on, say, an aircraft by making it go down by reducing unplanned downtime just a little bit, the customer makes more money, but then so do we. And a lot of the value of this isn't going to be driven by just top-line sales of new solutions. It's going to be bottom-line optimization and productivity. And that's where the real money is here. And, I'll go to the last point. This is a long journey, right? We just started this. And this is going to, we had an internet boom in 2001, where we had some inflated asset prices. Will there be an industrial internet boom? I don't know. Will there be an industrial internet bubble? I don't know. But one of the things we learned from the internet bubble in 2001 was that a lot of the predictions actually ended up coming true. It just took a little bit longer. People did move most of their music and book purchasing online. It just didn't happen in 2 years. It took about 10. Right? And so our assets that we sell live a long time. They live 10 or 20 years, and those assets are going to turn over. And so, we're in this for the long haul, but this is going to happen. There's just too much money in this for it to not happen, too much value to be created for our customers and for the economy. So I'm going to finish with that, but let's talk about how GE is approaching this and sort of what's underneath all these solutions. It starts with research. It starts with subject matter expertise. We have a 5,000-person organization called GE Global Research that's based in New York. Most of those people are PhDs. They're studying biomechanics, electrical engineering, chemistry, all the science and physics underlying our devices, and nobody understands our big machines better than we do. So that's our kind of core competitive advantage. But it's not the only thing that we're doing. So it starts with research. But we're doing 3 other things. The first is around our organization. We have built, as I mentioned, a software center in San Ramon. We have standardized our software development methodology across the company using agile, lean startup processes. And we have created, GE is fairly notable for its leadership development programs, and we've created software tracks now for our leadership development programs. We have not just a software center of excellence in San Ramon, but we have 3 sub-centers of excellence. We have one in cybersecurity, we have one in advanced analytics, and one in user experience. These are 3 key advantages for us going forward. The second thing is architecture. We have developed something we are branding Predix as the architecture, the technology architecture that's underlying a lot of the big data and analytics examples that we're building. The ones I just talked about, most of them run on this underlying architecture, because it turns out that the bottom 70% of the technology stack, whether you're talking about aviation big data problems or oil and gas big data problems, is kind of the same. Databases are needed in all of these things. Hadoop clusters are the same. Middleware is the same. How you detect intrusion and prevent intrusion from a security standpoint, it's the same. So all of the big data industrial internet solutions we're developing, GE, are running across a common platform, even though they're in vastly different businesses. Now, the top 30% or so of the applications are still industry-specific knowledge, industry-specific algorithms perhaps, but a lot of it can be shared, and we're sharing that, and a lot of it we've developed. Some of it we've developed ourselves, some of it we're getting from third parties, and some of it is open source. So this is our Predix platform that's powering all of our industrial internet solutions. And the third thing, and this is the one that's nearest and dearest to my heart, because this is the group that I manage for GE Software, is our ecosystem. We know that we can't do this alone. We can't make all the technology, write all the software that we need to bring the industrial internet to life. So we have a program of basically doing 4 things to build this industrial internet ecosystem. One is we're doing technology partnerships, where we're basically OEMing interesting technologies that we can't make ourselves from large providers. A second thing we're doing is strategic alliances. Developing jointly solutions with strategic partners and then taking to market jointly through things like joint ventures. Third is venture capital. We manage a venture capital fund for software, and I'll tell you about a few of the things that we've invested in here in a second. And fourth is M&A. We do have a program of looking at companies to acquire when we decide that we need to own a capability outright. So let me talk about a few of the things that we're doing in this ecosystem, because this is some important partnerships for us. AT&T, we announced our partnership with them recently to do basically interconnect for global networks, and we have a great relationship with them and have for a long time. Cisco, we're taking our Predix architecture and we're going to see if we can embed it on a line card inside routers and switches so that we can ship Predix-ready, industrial internet-ready internet equipment. Intel, we're using some really interesting real-time operating system software from Intel, and by real-time I mean deterministic. One of the interesting technology areas we like to look at is what we call real-time or deterministic technology. That's where you need an operation to happen exactly 30 times a second, not 29, not 32, but exactly 30 times a second. And on critical infrastructure, on aircraft wings, you need that level of precision. And we're working with Intel to develop some things in that area. Amazon is our first cloud provider that's going to meet our industrial internet standards, and we're working with them. Accenture, we've got a joint venture with Accenture that we announced in January called Teleris, where we're jointly developing solutions for the the airline industry, one of which is one I talked about earlier, where we schedule flight crews and parts and mechanics to all meet in the right place at the right time based on data that we're getting that predicts downtime before it becomes unplanned downtime. So we're taking some of the cost out there. This is my favorite thing to talk about. Some of the companies you may not have heard of. These are little venture-backed companies, and well, Pivotal's not small, but I'll tell you about a few of these. Pivotal, we invested $105 million in Pivotal earlier this year. Pivotal's a spin-out of EMC and VMware. They're doing a really wonderful Hadoop distribution that we're standardizing on. Their Pivotal One platform is going to be the platform as a service technology for us, and we think for the whole industrial internet. In fact, even IBM, which had been, I think, competing with them at some point, has endorsed the Pivotal standard, at least, for open source platform as a service, and this is great. So we're really happy to be working with the Pivotal folks. Lots of really great platform technologies in there. Prediction software, here's an interesting one. One of the biggest problems we have with the industrial internet is there's not enough data scientists. It's a really scarce resource. You have to take a complex analytic problem to this PhD, and he takes it, he looks at it, he has expensive tools. It's a little bit like winemaking. He goes off and crafts a handcrafted solution, and some problems are just like that. They're that complicated. But that takes a long time, and you can't get service very quickly. But there's a lot of problems that don't have to be that way. Microsoft Excel is a tool that's used by every single one of our customers. And it's their preferred analytic tool. The problem is it's just not a very good one for big data. It doesn't run in the cloud. It doesn't talk to Hadoop, which is where a lot of industrial big data will sit. It doesn't have the right set of algorithms embedded in its toolbars to use. Prediction has built a product that solves all those problems. They're getting a lot of great traction in healthcare. They're getting traction with oil and gas and with defense. So we've invested in this company. Accenture invested in these guys. They've standardized on them for their big data. Really interesting way to democratize analytics, right? Because a big bottleneck in big data is what do you do when you run out of data scientist capacity? Another interesting one is this company called AOSD. This technology actually gets used in the NBA draft in the United States to work through data sets of basketball players. But we're using it for industrial data. If you have a massive cube of data that it takes a week to crunch through, hard to get a result, and you don't know what you're looking for. You're looking for anomalies in massive data sets. It takes a while. How do you know what's important? This technology analyzes very quickly and then represents in a very compelling way complex big data problems. So imagine a big sphere of data. This company picks out an anomaly in that data and represents it like as a solar flare on a sun, right? And then you have an expert who comes in and decides if that solar flare matters or not, because you still need the human in the loop to decide if this anomaly in the data is relevant in this large multi-dimensional data set. And it turns out that we can decrease the cycle time of solving complex analytic problems using this technology. It's really, really interesting. I'll talk about one more. Theta Ray, it's a little Israeli company. They're doing inline anomaly detection. How do you know what bad behavior on a wire looks like if you don't have a database of past bad behavior to look at? Right? This is interesting for us. Security is really important. It's probably our most active investment area. So point is, a lot of interesting innovation out there in big data and analytics. We're investing in some of these companies. There's a couple other things I'd love to tell you about. They're still under non-disclosure, but we have an active venture portfolio, and we're really excited about this. So I'm going to finish, because I'm between, I think, us and lunch, with a macroeconomics lecture that everybody's going to love. But why is this so valuable for us? Let's talk about something we call at GE the power of one. A 1% or 1 mile an hour or a small incremental improvement in productivity actually drives massive, massive value for our customers. Remember the rail solution I talked about earlier. If you can improve the network speed of the trains by 1 mile an hour, over a 15-year period, which is kind of the horizon that we're using for a lot of this, over 15 years, $27 billion of productivity of cost out. These numbers, by the way, were calculated by our chief economist. Everything I'm about to tell you comes from a guy named Marco Annunziata, and there's a great white paper available in tremendous detail on some of these figures on our website. I would encourage you all to take a look at it. It's fascinating. $27 billion of value in rail. If you can take 1% of cycle time and cost out of the healthcare system globally, that's $63 billion over 15 years. If you can reduce, in our gas turbines, 1% of fuel, that's $66 billion by optimizing gas turbines using big data and analytics. Aviation, a couple numbers not on the chart, $30 billion, 1% of fuel. We're piloting this solution today, right? And they're saving 1% on fuel. It's a huge cost, $30 billion over 15 years. Finally, oil and gas. Very capital-intensive business. If you can improve the capital efficiency of the oil and gas industry by looking, doing one less check on the undersea blowout preventer a year and all the other things that are part of that ecosystem, that's a $90 billion benefit to that industry over 15 years. The numbers are staggering. And it's not just about what's good for GE or what's good for GE's customers even. This is going to affect the industrial internet is going to affect the entire global economy. Here's an example chart from our economics group from energy production and consumption. What they've done is decompose global energy production and global energy consumption. The production is the blue, the consumption is the purple. With some loss in the middle, we take 13 billion, lowest common denominator, barrel of oil, right? You convert coal and gas and wind to barrels of oil, you get 13 billion barrels of oil a year produced, $9.5 billion consumed, and there's loss in the middle. What's the point of this? We mapped this against our industrial internet efforts. 100% of global industry production is going to be impacted by the industrial internet, and about 44% of energy consumption in heavy-duty transport, which is heavy rail, aviation, or manufacturing, is going to be impacted by the industrial internet. We've calculated that roughly 45% of global GDP could be impacted by the industrial internet. So what? The power of one. Let me switch gears and come to the point. This is labor productivity in the United States over the last 60 years. You can see a couple of peaks and a couple of valleys. The first peak was after World War II when the US had a large intact industrial base and most countries didn't. The rest of the world caught up eventually by the mid-60s, and we had, in the US, a productivity trough. The next productivity spike was the internet revolution, started in 1996 when Netscape launched. We had, for a while, a much higher degree of labor productivity growth in the US because of the internet revolution, and that ended in the mid-2000s, and now we're in a trough. What does a 1% improvement in productivity applied to 45% of the global economy mean? What does that mean? It means $15 trillion in incremental GDP growth over the next 15 years in the world. That's a lot of value, not for our customers or for us, but for everybody. It impacts income. This is US data. $50,000 is the median US income. What is a 1%, the medium case, a 1% factor productivity in the sectors of the economy that we're talking about here, the industrial internet, mean for incomes in the US? An 8% increase by 2020 and a 20% increase by 2030 if it develops the way we think it may. The industrial internet is going to be a big revolution, not just for GE and not just for GE's customers, but it has the potential to really change lives. And hopefully I've given you enough facts and data here to back that up and talked about some ways that we're doing it for real. It is early days. It's going to take a little while to get there, but this is real and it's inevitable. So thank you. Thank you all very much for having me today. Let's enjoy some lunch and take care.